Hello, and welcome to G Fun Facts Online, where we decode the fascinating science behind our world. Have you ever looked at a blurry photo and thought, well, I can't tell if that's a sparrow or a finch, but it's definitely a bird? It turns out we're teaching artificial intelligence to think the exact same way. Today, we're diving into a smarter approach to AI image recognition called hierarchical classification. Let's get into it. For years, when we asked an AI to identify an image, it used a method called flat classification. Think of it like a multiple-choice test with only one right answer. The AI looks at a picture and has to pick one label from a giant list: golden retriever, poodle, beagle. If the picture isn't perfectly clear, or if it's a breed the AI doesn't know well, it might just get it wrong or give up. But our brains don't work like that. We see a furry thing with 4 legs and a tail, and we think animal, then mammal, then dog, and finally golden retriever. We naturally organize the world into categories and subcategories. This is the core idea behind hierarchical classification. Instead of a flat list, it organizes information into a tree-like structure, a hierarchy. The AI makes a series of decisions, moving from the general to the specific. This is a game changer. If an AI sees a low-resolution image of a bird, a flat classifier might fail completely. But a hierarchical model can confidently say, I am not sure of the exact species, but I know it's a bird. That's still incredibly useful information. There are a couple of ways to build these knowledge trees. The simplest is a strict tree, where every category or node has only one parent. For example, Siberian Husky falls under dog, which falls under mammal. Easy. But sometimes things fit into multiple categories. A tablet, for instance, could be an electronic and also a computing device. For that, AI uses a structure called a directed acyclic graph, or DAE, which lets a category have multiple parents. Now, how do we teach the AI to climb these trees? There are 2 main philosophies: the local approach and the global approach. The local approach is like hiring a team of specialists. You could have one expert for each branch of the tree, trained to decide between its direct children. So one specialist decides if an animal is a mammal or a reptile. If it picks mammal, the case is passed to another specialist who decides between dogs, cats, or bears. This is a popular method, but it has a weakness. If that first specialist makes a mistake and calls a lizard a mammal, every decision after that will be wrong. This is called error propagation. The other option is the global approach. This is like having one super genius model that looks at the entire tree all at once to make a final decision. It avoids that cascading error problem, but can sometimes struggle with the tiny details in specific branches. So why go through all this trouble? Hierarchical classification has some huge advantages. First, it's more interpretable. We can follow the AI's train of thought down the tree, which helps us understand how it reached its conclusion. Second, it's more flexible with uncertain or low-quality images. Third, it's much easier to manage. If your AI is great at identifying mammals but terrible with birds, you don't have to retrain the whole system. You just send the bird specialist back to school. A study on classifying Amharic news text found that while a flat classifier's accuracy dropped as more news categories were added, the hierarchical approach actually got more precise as it moved down the tree, from politics to international politics, for example. But, as we mentioned, it's not perfect. That problem of error propagation is a big one. A single wrong turn at the top of the tree can lead the AI to a completely incorrect conclusion at the bottom. Another challenge is data. It's easy to find millions of pictures of animals, but much harder to find thousands of pictures of the green hermit, a specific type of hummingbird. These deeper, more specific levels often lack enough training data. And then there's the consistency problem. You don't want your AI to label an image as a green hermit on the most specific level, but call it a plant on a more general level. The labels have to make sense all the way up and down the tree. Luckily, the field is moving fast. Researchers are developing brilliant solutions. New models like HCAST are designed to ensure consistency by making sure the AI is looking at the same part of the image when making both its broad and specific classifications. We're even using large language models, like the tech behind ChatGPT, to automatically build these classification trees. The LLM reads through all the possible labels and groups them together in a way that makes logical sense, just like a human would. This smarter, more nuanced approach to AI is already shaping our world. It's being used for everything from monitoring wildlife in remote forests and helping autonomous vehicles understand complex road signs, to organizing massive online shopping catalogs and even aiding in medical diagnoses by classifying cell types. By moving beyond simple labels and embracing a structured, layered understanding of the world, hierarchical classification is paving the way for a more intelligent and capable generation of artificial intelligence. It's teaching our machines not just to see, but to understand. Thanks for tuning in to G-Fun-Facts Online. Join us next time for another look at the science that's changing our future.